Welcome to 2018 Higher Level, Section C. It's the Geological Geometry question, question C1. So, the accompanying map, okay, so this would be at the back of your Section C or Section A in the actual exam. Shows the contour, so it shows ground contours at 5 metre vertical intervals. Okay, so we've got in 5s here. AD is the centre line of a proposed motorway. So we've got a motorway running from A to D. The motorway is widened between B and C to form a toll plaza as shown. So as we're going along it, widens out just so we have a space for our toll plaza in this area. The motorway has the following specifications. The portion from A to B is level at an altitude of 65. So A is at 65 and B is also at 65. The portion from B to C is level at an altitude of 65 and is widened as shown. So C here is also at 65. The portion from C to D is rising uniformly at a rate of 1:15. Okay, so it's rising up, so like going up a hill, okay, at a rate of 1:15. Okay, so we'll come back to that when we need to deal with it. Using slopes, side slope is 1:1.5, so for cut, 1:1.5, and for 1:2 for our embankment, so our fill is 1:2. Complete the earthworks necessary to accommodate the motorway between A and D on the northern side. So we just need to do it north, south, east, west. North is this side, so we just need to do it here. We don't need to worry about the southern side. You may ignore the southern side. Brilliant. So, if we're thinking about our cut and our fill, okay, we're running 5mm intervals. So, if I'm cutting in, I'm up at 5mm interval, so it's going to be 7.5. 5 by 1.5 is 7.5. And our fill, we're up in 5mm intervals again. So 5 by 2, 10mm. So we're going to be 10mm intervals going out there. So let's have a look now at our question. We're at 65 here for A. Okay, so 65, for A, and we can see here that all these measurements at A, we've got 50, 50, 55, 60, so those are all underneath the level of the road. Okay, my road's here, all those are sloping down away, so I need to fill in that position. We say that our intervals there are going to be in 10mm intervals. Every 5 meters we go, 5 meters we go down, so let's go 10, 10, 10, and maybe 65, 60, 55, 50, that should be enough. So let's draw those. Okay, so I'm here at road level, which is 65, okay, which is right there, 65, gives me a point. Then I'm going down because I'm filling 60, 55, 50, and there's maybe another point out there, so that's fair enough for us. So let's draw in that curve there. Alright, so that's my fill. We're still at a level 65, but we can see now our contours are at 70, 75, 80, 85, 70. Okay, so what we're going to be doing here is we're going to be cutting into the mountain, cutting into the hill. So looking back at our cut, every 5mm we go, it's 7.5 of a cut, or interval. So we're on 7.5, so let's go 15, and then in the middle is 7.5, yeah, 15, 7.5, Okay, and that should be enough because I'm at 65, 70, 75, 80, 85, and there's no 85. Okay, so draw my contours, or draw my intervals. So I'm at 65 at road level, then I'm going up because I'm cutting in. So here I'm going to be at 70, so 70 is there, then up to 75, 80, and extend around, then I won't intersect. Just extend it on there, so that doesn't intersect, so I just have this line here, start my fill. Okay, probably would have created another point away up there, but we'll be finding another intersecting line coming across. So we're still at a level of 65, and my contours are at 75, 80, 85, so I'm still going to be doing my cut. So let's go. I'm writing my measurements here again. 7.5, 15, and 7.5. We went up to 100, 65, 70, 75, 80, 85. Okay, so I'm at a level of 65, this is 70, so let's look for any 70 contour, 75, I'm going to need this to intersect, so let's start over, so I'm using 75, 80, so 80, 90, sorry, 80 and 81, and then 75, stay at 75, up to 80, 85, 90, 95, 100, 100 again, 95. And that should be enough. So, yeah, my contours coming around for my cut. I might need to find another there. Let's show that. So, there, down to 85. Okay. Now we're still at a level of 65. So let's slide set squares. Just get a perpendicular measurement. So 7.5, and we do intervals again. Slide set square. I don't need 80. Okay, so 65, 70, 75, 75, 80, 85, 90, 95. I'm going to have to put up another line there, but continue on. 75, 75, 80, 80, no, 80 there again. and down to 75. So let's just draw in what I've got so far. Okay, and come up another bit. So that 65, 70, 75, 80, 85, 90, 95, 100. Okay, so 100 is the highest. So that's all I need. One more line. That's all 100 and that's 100 again. Okay. Okay. So there are all my contours as far as point C. So with C to D, we said it rises uniformly at a rate of 1 to 15. So for every 15 I go out, I'm traveling up 1 meter. Okay, so let's see, can I go up, travel up 10 meters? So if I want to travel up 10 meters, I have to move out 150. Okay, so that's going off my page. So let's see, can I travel up to the next contour? So I'll go from 65 up to 70. That'll be going up 5. Let's draw a little sketch of this. Yeah, 5. So 1 by 5 gives me 5. 15 by 5 gives me 75. So if I measure out here from C, 75 millimeters. At this point here, it's going to be at 70. Okay, so that's at 70. That's perfect. Right, and looking, are we doing, so we're rising, so we're going to have to create a cut cone. Okay, we're at going between 65 and 70, and underneath, the road is underneath here, so 85, 70. So I'm going to have to cut for a portion of this. Okay, and then I'm going to have to fill. So cut, my cone there is going to be 7.5. I'm just going to use what I've got here, my measurements here, to draw that 7.5 distance. So that's my cone. I'm traveling from here to here. Okay, so that now is at a height of 70, that line. So now I'm going to go out and 7.5 millimeter intervals again. Okay, so that's 70. Point at 70, and we're at cutting in, so 75. That's not even so stainless. Point. So, going up. Oh, this is a little heavier. So contour there, and I need to go underneath the road. And it's 7.5 again. Sliding set squares. So that's at 70, this at 65. So there. Okay. Now, once I hit the road here, you can see that we're underneath that level. We've gone from 70, 65, so I'm going to have to fill in over here. So, radius of my fill cone is going to be 10 millimeters. At 70. Slightly. As you can see my cone there. Right, and that, then we're going to join that to C tangentially. Okay, we're going 10 millimeter intervals here. So we're at 65 from here. 65. I'll give me a point. We're at 60, 55, 55, 60, 65. Just to finish off, I need to extend this on from a point at 70. Okay, so I've got a fill, and cutting all in between. Okay, so next on to part B. On the map we've got P, Q and R, and there are 3 points on the surface of the Earth. So P, Q and R, 3 points on the surface of the Earth. Vertical boreholes at these 3 points reveal a triangle at the top surface of a stratum of water at altitudes 45 millimeters, 60 millimeters and 35 millimeters respectively. So we've got 45, 60 and 35. Okay. In the space provided at the top of the map, draw the elevation of, sorry, I got that off the screen there, 45, 60 and 35. So in the space provided at the top of the map, draw the elevation of the triangular portion of the top of the surface of the stratum. So up here we've got our 35 height and the 4 extended out, or R extended onto it. So there's R. Okay. And so that's going 5 millimeter intervals. It's 40, 50, sorry, 40, 45, 50, 55, 60, 65. Okay, so Q is at a height of 60, so extend that up onto 60, which is 40, 45, 50, 55, 60. Q, and P is at a height of 45. P, 45. There is our PQR. Okay, so let's also draw PQR in plan. Okay. So that's what they've asked us. In the space provided, top draw the elevation and portion of the strata. Okay, done. Draw the plan of the triangle and determine the dip strike and dip of the strata. So the plan drawn, okay, and they want us to find the strike. So for the strike, I'm going to draw a level line. Let's take a level line here. Should use that green colour here. So my level line, project that down. Okay, so that is the strike. S-T-R-I-K-E. It's a true length line. Okay. Should have projected it down there. Okay. Now they want to find the dip, so I want to see this plane as an edge view, so I need to see the strike as a point view. So anywhere out here, I suppose in the white space they've got provided first there. Go 90 degrees to my strike, a little bit further. That's my X and Y line, and we'll check everything out. P2 and R. Okay, we'll take our heights. This is an elevation plan, auxiliary elevation. So let's take our heights and our elevation. So P, Q, Q, there, P, that's that point view of our strike, our dip in our, sorry, our R then, it's just in there. It's too small for my compass, so measure up 5 because that's the same height there. So here's my edge view. That's a point view of my strike. Okay, they're asking us for the dip. So our dip is going to be okay. Let's extend that on. That's my dip. Now measure the angle. Which in this case is 43 degrees. So 43 degrees. Okay. So we've found our dip and our strike of the stratum. Determine and indicate in meters the length of the shortest skew borehole from R to the top of the stratum. So an edge view of our stratum R is skew borehole so R, we're saying to the top surface of the stratum. Okay, so looking at this, R is okay, so that's our stratum. So R is at a height. Okay, we need a short skew borehole. Okay, so the hole around the dig is going to be at 80, so we'll go up 80, which would be, we're at a height of 35 at this R, Okay, we want to go to 80, so that's going to be 45. Yeah, 45. So let's measure a distance of 45 up from this borehole. Okay, or we can measure up 50 total, because this base XY line here is at 30. So there is R. Okay, and if I drill a borehole 90 degrees, that's going to be the shortest distance. Okay, that will give me my shortest distance at 90 degrees there. Okay, and they're asking me to determine it. Do I need to measure that? Not quite sure. Indicate in meters the length of the shortest screw borehole in R. So that there is going to be, let's extend this out. Where's my red pen? That distance is 30, I have a 33, 34, so about 34 meters. Okay, so final part, determine in plan the line of intersection between the top surface of the stratum and the surface of the widened portion of the toll. Okay, so the widened portion of the toll said is at 65. Okay, in the top surface of the stratum. So I need to measure up a distance. Okay, this is at 30, so I need to measure up 35. So I'll just say this is at 80, this is at 65. Okay, and now let's get the color here. From there, let's extend on my stratum. Okay, and where that this would be a line of intersection between the two of those. Okay, so that's my 2018 geological geometry question C-1.